Good evening, all. You are welcome to Tutorials with Faber Tandy, the schoolboy. Today, we'll take a look at our assignment review on physics. We review the last assignment on physics. The questions are as follows. Number 1 says, the dimensions ml squared per t squared represents A, momentum, B, power, C, work, D, pressure. Isoya. What's the answer? Work. How? How is it work? Come and tell us how you arrived at work. Fast. Come and tell us how you arrived at work. Chine, get the duster there. Fast. Are you done? Alright. Huh? Okay, what did you do? Explain to us. Shift like this so you don't block the board. So explain what you did.
Work equals to force times displacement. Force is equals to mass times acceleration.
Be louder, please. Be audible.
Acceleration equals to changes in velocity.
Can you hear him? They cannot hear you. Speak out now. You are speaking to the class, not me.
Acceleration equals to changes in velocity over time.
Can you see hear him? Can you speak to the class? See, anytime you are speaking before people, try to speak in such a way that somebody down there can hear you. Stay well and speak to the class. And you said what? Start from the beginning.
Equals to force times displacement. Force.
In fact, you see, because I'm close to you, let me go here and stay. Oh yeah. Is why I cannot hear you. Start from the beginning. Speaker, let me hear you. Start afresh. Tell us what you did, is Chukwu. We want to hear you. At the same time, we want to learn from you what you did. That's why I brought it out here. Oh yeah. Let's start now. Hey now, start. Give me the marker. Go and sit down. Now listen. If you have a question like this, look up. He started from work equal to force times displacement. Even though yes, this is what is it called? This is OBJ. So let's assume there is no option in this question. Why would you start from work? Let's assume this question. The dimensions L squared per t squared represents dash. Let's assume that this is a question. And there's no option. So how do you know that you should start from work? Is it because you saw work here? Do you understand where I'm going to? Is it because they gave you work as option? That's why you started for work. What if there's no option here? What will you do? That means you cannot answer the question, right? That's the meaning. If you are given this type of question, this is dimension. Change this dimension, move it to what? Units. From units, you get the what? Quantity, simple. By virtue of this dimension, it's clear that this is a derived, it will give you a derived unit. It's not true? Good. Now, you get the units. From the units, you get the what? Quantity. Simple. Now, let's look at this. We have, see, watch how I break down this thing now. I don't know what it will lead me to. I don't know what it will lead me to. Why I faulted you got the answer, perfect. But what if you were not given option? That's where I faulted your work. What if there's no option? How will you solve it? You first move the dimension to the unit first. The dimension is what? M what? L square per what? T square. You move it to what? Unit. This M is for what? Mass, right? Mass is a what? Kilogram. This L is for what? Length. Length is what? Meter. So L square is what? Meter what? Squared. This T is for what? Time. And time is what? Seconds, which is S. So per S what? Squared. Per S what? Squared. This will give you an idea of what this thing will give you. But you cannot conclude. You cannot do what? Conclude. You know, here we have kilogram. You look for, you may split this meter, this M square now. You may split it to see what it will give you to. You may split and say, okay, we have K meter dot what? Meter square. Can you see it now? Can you see it now? The thing has taken shape now. Kilogram meter dot kilogram meter square. You have splitted the what? This thing. Are we together? You can look at this thing now. What quantity can this meter per second square give you? What quantity is that? What quantity has meter per second square as its unit? What? Acceleration, right? I agree with you. Is it true? Is it true? Acceleration. This is what? Acceleration. Look at this kilogram meter. This one is already what? Mass. True or false? True or false? This kilogram is already what? Mass. Right? Why this is what? Let me write their name. As a reward, relation. This one is what? What? Mass. Right? Are you following me? Are you following? This one is meter. It remains this here is meter. It's a measure of length, right? Now, what quantity has meter? Length has meter, distance has meter, and what have you? Even displacement has what? Meter. But which of them goes more with mass and acceleration? In fact, mass and acceleration gives you what? 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 Mass times acceleration is what? Force now. Here is what? Force. This is what? Force. Force is what? Mass times what? Acceleration. True or false? And what is remaining is this meter. This meter is a measure of what? Distance, displacement, and what have you. Which of them goes more with force? Displacement. True or false? True or false? This is what? Displacement. So force times displacement is what? Is what? Work. Does it make sense to you? Does it make sense to you? Does it make sense to you? Yes. He jumped into work because there's option there. Work. And the question can be twisted. Anyway, JAMB will always give you option anyway, sir. But it's good to know it. Like a WAEC, you may not sit in WAEC. This can serve. Are you aware that this can serve as a good theory question in WAEC for those writing WAEC? Are you aware? It can serve as a good theory question for those writing WAEC. They just ask you dimension represent, or what does this dimension represent? You don't just jump and start saying work. You have to show how it's work. Move the dimension to what? Unit. Split the units. Know the one that is the one that will give you which one that will give you which. This is kilogram, this is mass. This is here now is meter per second. Is already what? Acceleration. This is meter, displacement. Mass times acceleration is what? Force. Force times displacement is what? Work. Is it clear? You said that now you enjoyed the lecture because I was vocal. But if I call you out here to talk, you will do like what I don't know on the board. You'll be consistent about these things. You don't want to change. I don't know why. You'll be consistent like this. You don't want to change. And I'll be talking about it. Each time I call you out to this board, you do what I don't know. You talk. That is not good for you as a man. Not just as a man. As someone that is educated. So they call it out to speak to people. You cannot speak to people. Is that what they're telling you? Is that what they're telling me? It's wrong. Please start me now to help you. All right, let's go to the next question. Which of the following is a fundamental unit? A. Newton. B. Watt. C. Joule. D. Seconds. I am okay. Chibuzo, what's the answer? What? Why do you say seconds? Is it what?
Newton once and Joule are unit of measurements.
All of them are unit of measurements. So why do you choose seconds as a fundamental unit? Why?
It's a fundamental unit.
Why? You don't know the reason. Izu, answer that one to relieve yourself. Do you agree with me? With him, he chose seconds. Why did you choose seconds? It's not.
It is not derived.
It's not derived. How? What do you mean by that? Not derived?
It is a unit from a fundamental quantity.
It's a unit of fundamental quantity. What's a fundamental quantity? What is a fundamental quantity?
Fundamental quantity are those quantities that are independent of other entities.
Okay, I think I agree with you. So the answer is what? Seconds. Seconds is a unit of what? It's a fundamental unit because is not derived. If you watch second, if you see second, the seconds is seconds. It's not. There's no combination of other units to form what second. It's on its own. It doesn't depend on other units, and it's the unit of a fundamental quantity, which is time. Time is fundamental. Time is not dependent on any quantity. So that's why the answer is what? Second. Newton. Newton is a fundamental what? It's a derived unit. Look at force. Look at force. Force, the unit of force is what? Newton. Force is derived from mass, meter, mass, displacement, and time. If you combine kilogram, meter, and seconds per second square, you form what? Force. Because kilogram is mass, meter per second square is acceleration. They come together to form what? Force. So force is a derived quantity, and the unit is what? Newton. So Newton is a derived unit. So it's not the answer. Watt is joule, energy per second. Joule itself, look at joule here. Joule is work. All these things we'll be doing here. This is the actual unit for joule. Kilogram, meter square per second square. This is actual unit for joule. But because of the scientists that worked on it, his name is Joule. They gave it that name, what? Joule. Are we together? So, Joule, watt is a derived quantity because it's derived from joule and second. So, joule divided by second will give you watt. So, watt is a derived quantity. Joule is a derived quantity. You've seen it here now. But it's only second. Second is not derived from any units. So all those ones are units of derived quantities. So they are derived units. Why seconds is fundamental. So I agree with him. This is the answer, seconds. This one is what? Work. Now let's go to the next one. Which of the following is a derived unit? I am Meruz. Number 3. Which of the following is a derived unit? Oh yeah. Which of them is a derived unit? Tell us fast. Which of them? You don't know. Chinaya. Newton. Derived. Why do you say so?
Because an express here with the help of fundamental units and dimension. Because it's derived.
No, compare with the options now. Don't just pick the one. Just compare with the options there.
So, like this kilogram will is a fundamental listing used for measure of mass. Then meter used for measure of length, Kelvin for temperature. Then that Newton is a measure of force. That Newton, and I express here like you see me a dimension, and
Stop. Speak English language, please. Speak a language other people will understand.
So that Newton,
okay.
We usually express it with the help of these fundamental units here.
Which one are fundamental units?
Kilogram, meter, Kelvin, seconds,
Okay, Newton is a derived unit. I agree with you, but your explanation is not smooth. Newton always try to make your explanation smooth. It's very important, please. It shows how the understanding you have in that thing. Newton is a derived unit. The same thing I'm explaining here. Newton is a unit of what? Force. Look at force here. Force is a derived quantity because force is derived from all these things. Force is mass times acceleration. So force is derived. It has a what? Formula. It has a what? Formula. So force is derived, and Newton is a what? Derived unit of what? Force. So Newton is a derived unit. Number 4. To determine the weight of an object, you could A. use a beam balance, B. use a spring balance, C. find the force necessary to give a certain acceleration, D. use any of the methods above. Kamsi, oh yeah. What's the answer? Tell us. Huh? B says what?
Use a spring balance.
Why do you say so?
Because you used to measure it to shape it.
How? How does it look like?
The spring shape, you just stand up with it.
Is that a spring balance? Chinwe, what's the answer? How is it B?
Because it's used to measure the weight of an object.
Huh? Sit up.
Measure the weight of an object.
How does it look like?
So Nigeria.
Shh. Speak English.
It looks like this.
Like how?
As in,
I don't understand. Draw it on your phone. Let me see. Draw it. Let me see whether you know what they're talking about. Even though we have not today this year, but it's good you research ahead. You learn how to research ahead. How does it look? Who has seen a spring balance here? So how does it look? What is it used for? So how does it look?
Look like a clock that has a hammer on top.
Mm-hmm.
And under it, where the weight of the object will be held.
Under it. Okay, good. Izuku has an idea of what it looks like. Izuku has an idea of what it looks like. Something like this. Just a sketch anyway. We'll see 3 Look at how it looks like. The weight, what you want to weigh, the weight you see here, you put it, you take the reading here. As it goes down, it will take the actual weight here. Are we together? It's a Newton. Now let me explain. You know, sometimes I told you before now that they normally interchange weight with mass. They're not exactly what? The same thing. Most of those ones you are seeing, those are checking the mass. Those ones is in kilogram. They check the what? The mass. You are weighing, beam, balance, all those ones. They check the what? The mass. Look at this, all these beam balance, name them. Beam balance. All other ones are just telling long stories. Beam balance is the only thing that makes sense here. This is for what? Mass of an object. This one is for what? Mass in kilogram. But spring balance is on what? Is what? The weight. Look at it. You know that the weight is a force, not what? In kilogram. Weight is in Newton. And weight is a measure of what? The force of gravitational force acting on the what? On the body. Am I complicating? That's why weight is equal to mass of an object times what? Acceleration due to what? Gravity. Weight is mass of the object. Weight is mg. Mass of the object times what? G. M is the mass of the object. G is the what? Acceleration due to what? Gravity. So weight is what? So when the body weight is mg, that's why it's in Newton. So when the body is suspended, it's suspended under what? Gravity. Am I communicating? That's when you can actually get the what? Weight. That's why you use what? Spring what? Balance to actually get the weight. So the answer is what? Spring balance. But even in most cases, they say you want to weigh something, you are weighing something. You just use them interchangeably. But in physics, if you want to talk about weight, it's actually a force. Are we together? So if you're not careful, you go and tick beam balance. So far you are in physics class, don't tick beam balance. It's wrong. It's spring what? Balance. Okay? All right. Now, next question says, what is the least possible error in using a rule graduated in millimeter? Sorry, in centimeters. What is the least possible error in using a rule graduated in centimeter? Come see, what is the least possible error? No, don't come see. Sit up.
0.1.
0. What?
1 centimeter.
Why did you choose 0.1 centimeter?
So I only doing like the way you taught us yesterday. I wasn't in class when you taught us something, but the way you taught us yesterday about that micrometer screw gauge, we were looking at the division, the main scale on the way. So the main scale, it will have it will be in millimeter. Then, for example, even on the division.
Who can explain this, please?
So that was like 0.1.
How?
Because the calibration is cm, lowest calibration.
Lowest calibration. That's the word. That's the word. The lowest is what? 0.1 cm. That's the word. If you get a meter rule, check it. The lowest calibration there, the lowest gradation is what? 0.1 cm. Check your meter rule. I've explained it several times. So, and that will give you the least possible what? Error. At the same time, the what? Accuracy. Are we together? The what? Accuracy. So the answer is what? A. The answer is A. Okay. Number 6 says, a man walks 1 kilometer due east and then 1 kilometer due north. Full stop. His displacement is A. 1 kilometer north, 15 degrees east. B. Route 2 kilometer north, 45 degrees east. C. 1 kilometer north, 30 degrees east. C. D. Route 2 kilometer north, 60 degrees east. Izu, I've come back to you. What's the answer? You not solve it. So what's the answer now? Okay, you did another attended any answer. You stopped. You gave up. Okay. You uncle. Since you came here, have you tried to solve it? So what did you get? You say what?
Not get the answer.
You don't get the answer, or you didn't solve it. Which one? Chichine, did you solve it?
You need to ask me.
Did you solve it?
No, sir.
So none of you solve it. Chiwa, did you solve it? Sit up. This is not a class attitude. It's very wrong. In class, your posture in class affects you. I've been saying this time. I've been saying this thing. The way you sit in class affects your understanding of whatever is going on in class. Kamsi, did you try it, solving it? I know that people will not solve this one, but it's okay. Let me skip it for now. Let me go to number 7. The accurate instruments to measure the thickness of a piece of paper is A. Meter rule, B. Micrometer screw gauge, C. Spherometer, D. Vernier calipers. Vernier calipers. Vernier calipers. Is that right? Go on. I'm starting from those that are not come for tutorials, and it's showing they are confused. You. It's clear. It's clear that they were not there. You. Go and call. What are you looking for? Go you. Micrometer screw gauge. The answer is what? Did anybody bother to check what is spherometer? You. Who else bother to check it up? Those that were here when I gave the assignment. Who else bother to check what is spherometer? Did you check? Did you check window? Why? Why? This same thing I have been saying in this class. How can you say you do the assignment? You see a word, you don't even know what it is. You get quiet. You didn't check it up. Why? Then what did you do? You just look at it and saw the one you know and did them on the father that the answer is there. Did you bother? Why didn't you bother to check up what is spherometer? And I'll be telling you that if you see some words you're not familiar with, look it up. That may be your opportunity to see that word on the normal. You don't know where you meet yourself tomorrow. A question can come up from that. What is spherometer? Is it? Instrument used to do what? Used to measure the circumference of a what? Circle. China, is it true? Browse it. Let's see whether it's true. You have data. You have food. What is your problem? What's going on? Hey, now wow. Be fast. Let me solve this number 6 then. I am not yet happy with the feedback I get each time I give you assignment. I am not so familiar with it. These things are past questions. These things are past questions for the exams you are preparing. And I know why I give you past questions, so that I want to model you the exam you want to write. But that doesn't mean that you should just go online and take it out, go anywhere or get the password and take it and jump. I'll be taking the answer for me. You are not helping yourself. Try to know the reason behind it. Even if you see the answer online, fine. But find out the reason behind it. Why this is the answer. That is when you know that you have actually done the what? Assignments. What is phenomenon?
That is used for precise measurement of the radius of curvature of either sphere or a earth's surface.
Say what?
An instrument that is used for precise measurement of the radius of curvature of either sphere or a curved
Curvature. Look for under the definition. Is that the definition there? I want to justify what he said. Curvature. Circumference.
A spherometer is a device that does just as its measurometer is fair, but its measurometer is fair.
Doesn't know how to check something online. Okay, now why? Open that thing. What is you said is correct anyway. But I want you to see it by yourself. Read that thing well. Is there circumference of a what? Great circle. Curvature. Whether they call it radius of curvature, is still what? Talking about what? Circumference. All right. Let's continue. Look at this. Number 6. A man walks. This thing is under displacement. We'll see 3 things under the topic we are in now. But I just want to introduce it so you will prepare yourself. My joy, why I'm not happy is this. I want set of students I'm teaching. I want students that study ahead. That's why I'm still not happy. I am still not happy with you guys. I'll tell you the truth. I am still not happy with you. There's a difference between that. You give assignment, your student will go home, get this book and read. Even if they don't understand it, they have read it. I'll come to us and say, sir, we have done the assignment. Look at. But sir, this is what I read, but I didn't understand what they're saying. This is what I want to be hearing from you. Or you just come, look as if you just carry a book, go home and dump it, and do that thing, and come again, carry it and come out. It's painful. I am not happy about it. I was then I will go home, see these things, they come from, each of these things has a topic they come from. Go through it, even if you don't understand it, at least read it. It's when you start reading, that is when you realize that you need to read. That way you learn how to sit down and read. People have not learned how to sit down and read. That's what I want you to start doing first. You always want a sharp and a shortcut. And I don't like it. It's not a good thing for you. I want you to learn how to study. I don't have these textbooks at home. What is your problem? I want students, a class that is challenging. When you come, you have gone through it. Even just go through it first. Try to see what it is. This is what I'm saying in class. What is it? Say, look at it. Look at these things. Know what they are. I'm not saying you must master everything at once. No. But the idea that you have read it, there is joy it gives when you come to class. You have read something, even if you understand it. At least you have gone through it. When I see students that have gone through that, I know them. You people have not yet got to that level, and I don't like it. It makes me uncomfortable. That's why I give this instance ahead of time. I could have just said, go and read up this and come. I know, but I do it. I give it before assignment, so that if you see a question, try to solve that question will lead you to go to textbook, to go through that topic and see whether you can solve that question by reading that topic. And before it was going on, you would have gone through that topic. Now look at this thing. This thing has to do with what? Displacement. Distance and displacement. In your secondary school, you did bearing, right? Right? Good. You know what is a cardinal point, right? With a cardinal point, you can solve this question. And you know you are right angle triangle. You know the angles in the triangle, right? You know your Pythagoras theorem, right? Right? You know your bearing. Then what's your problem? Then what is your problem? If you know all these things I have been calling thesis, then why didn't you apply it here and solve this question? Now, look at this thing now. A man walks 1 kilometer due east. First of all, you start from where the man started. Look at where the man started. You draw a cardinal point there. This is what? Cardinal point. North, south, east, and what? West. It's not. This is north, south, east, and what? West. Now, this is where the man started. We call it what? Point A. They said the man traveled. Stand up. Stand up. They said the man traveled due east. Don't sleep there. Sit well so you don't sleep. They said the man traveled due east. This is east. This side is what? East. True of us. This side is what? North. This side is what? West. This side is what? South. So if you hear due east, it means the man continued in the east direction. It means the man continued in the what? East direction. That's the meaning. Due east. If they said due north, it means the man continued in the north direction. Until I say, or if they say due south, continue this way. So he said the man traveled what? Due east for 1 kilometer. So the man traveled like this. Go 1 kilometer, Kose. Yeah, 1 kilometer. Kose. They said due 1 kilometer due east. After 1 kilometer, he stopped. I said, then 1 kilometer due north. This is where the man stopped. There should be another cardinal point here. There should be another what? Cardinal point. Because this is where the man what? Stopped. This is still what? North. Here is what? West. Here is what? East. Here is what? South. The man got here, 1 kilometer got here. He traveled under 1 kilometer due north. He continued like this due what? North. The same distance here. 1 what? Kilometer. And stopped here. You put another cardinal point. Here is what? North, south, north, east, south, and what? West. Watch out. The man started from here. Traveled due east 1 kilometer. From here, he changed direction and traveled due north, up, and stopped here. The same 1 kilometer, 1 kilo. Here and here will be the same size. Here is 90 degrees. True of us? True of us? They did not ask. His displacement is what? Look at it now. This is where the man stopped. By displacement, you check where the shortest distance from where he started is the what? Displacement. Okay? This is the man's displacement. Here. But displacement has a direction, the angle, bearing from where he started from. I will explain that. But this is where the man stopped. From here to here, will give you the man's displacement. But if you want to calculate the distance the man traveled, distance the man traveled is what? Which is what? Which is what? Which is what? Which is what? Distance the man travel is what? 1 kilometer plus 2 kilometers. But displacement is the shortest route from here to here is the man's what? Displacement. Are we together? Now, but displacement must have angle because it's a what? Vector quantity, right? Even though we will still treat vector quantity, but it's a vector quantity. Now look at it now. If you want to check this man's displacement, you check this magnitude. Magnitude is the magnitude, the size of it, and the what? Direction. The man make angle here. This place there's an angle here, right? This angle, we call it alpha. This angle and this magnitude is what will give us the man's what? Displacement. So we should calculate this, what is here first, and calculate this angle. So how do we calculate this angle? It doesn't say you sit down. And how do we calculate this angle? Watch out. Here and here and here. This is a right angled what? Triangle. True or false? Now, if this is a right angle triangle, watch out too. Here is angle what? 90, right? Angle what? 90. Here there should be an angle here. What angle should be here? If it's a right angle triangle, what angle should be here? And what angle should be here? Let me bother you. I know this angle should be equal. Hope you know. Plus nka is 180 up here. So a bottom should be what? To add here to be one. Ever should 45. Ever should 45. Right? 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 Do you with me? But let's take it step by step. Now, we need to find, we know this side. We know this one. We need to find x using what theorem? Pythagoras theorem. Pythagoras theorem said that what? This is the hypotenuse of here. The square of the hypotenuse of the right angle triangle, right, is equal to the sum of the square of the what? Opposites plus what? Square of square of the opposite plus square of the what? Adjacent. Pythagoras theorem say that hypotenuse square of the what? Hypotenuse is equal to what? Square of what? Opposite plus what? Adjacent. This is Pythagoras theorem. So from here now, which side is hypotenuse? The longest side is what? Is what? Which is what in the diagram? X. So that means x square is equal to what? Opposite is where? One what? Square. Plus adjacent is what? This one. One what? Square. Therefore, s square is equal to what? 1 square is what? Plus 1 square is what? Which is what? Therefore, x is what? Root 2. Good. X is what? Root 2. So, x is root 2 what? Remember here is kilometer. So here should be what? Root 2 what? Kilometer. But it's not enough. Displacement has two sides. It has, sit down, don't sleep again. Displacement has two sides. It has the magnitude and the what? Direction. That's why it's a vector quantity. Displacement has the what? Two sides, magnitude and what? Direction. That's why it's what? A vector what? Quantity. That's why it's what? A vector what? But it has a what? magnitude and what? Direction. Now, if that is the case, we have calculated the magnitude, which is what? Root 2 kilometer. Let's calculate the what? Direction. For us to calculate the direction, we must do what? Find this angle. You have said from deduction, I agree with you. From deduction, I agree with you that here is what? 45. But we need to do the calculation to be sure. For me to show you that it's actually what? 45. Let's go to our trigonometry again. What is, if this angle is theta, let's find this angle. This angle is theta, and here is 1. Here is 1. Here is what? Opposite, right? And here is what? Adjacent. Here is opposite, and here is what? Adjacent. Now, what is tan? Tan is what? Tan theta is what? Opposite over what? Adjacent. So, tan theta is what? Opposite over what? Adjacent. Tan theta is opposite over what? Adjacent. Now, from here now, what is opposite? 1 kilometer. Adjacent is what? 1 kilometer. Therefore, tan theta is what? 1 kilometer over what? 1 kilometer. Kilometer will do what? Cancel kilometer. Are we together? That means tan theta is what? 1. And if we want to find theta, we do tan inverse, right? So theta is what? Tan inverse of what? 1. Check tan inverse of 1. Punch your calculator. Use your phone, sir. If your phone has scientific, you can see it there. What is it? Oh yeah, check tan inverse fast. Just punch tan inverse, then write type 1. Second function now. Go to the second function. Press tan.
I don't know what the second function is.
Hey, Aju.
Open the page.
Oh yeah, open it again. Turn it. Check it. Invert. Julia? Inversion. Press that tan inverse and type 1. So theta is what? Tan inverse of 1 is what? What do you press?
Tan inverse, then I pressed 1.
Press it again. Close the brackets. This is in radian now. Put it in degrees. You see, this is radian. Shift it to the degree. See the degree here now. It's now in degree. I have to do it again. That was in radian before. Put it in the degree. Times the 1 is what? 45 what? Degrees. So here is what? 45 degrees. Are we together? Maybe in a manual too. Why not come to the front here so you can see it very well? Again, as known as a manual too. Come front. There's spaces here. Now, is what? For 5 degrees, right? Now, remember that Here is, from here to here is what? 90, right? So if here is 45, here is now what? Here is 45. Are we together? So that means angle here is what? 45 degrees. See what it means. See what it means. Bearing from here to where? Here. So the man's location presently is in between north and what? East. Related to where, from where he started from. Is in between north and what? East. Is in between what? North and what? East. In between what? Chinwe. The man's where lies where now? The man's location lies where? North and east. Is that what I said? But by which angle is not 45 degrees what? East. Hello? We agree that the man's location is between what? North and what? East. By which angle? By which angle is what? Not 45 degrees what? East. It's like this. This is now, let me bring out this place. It's like this. Here is north. Here is what? East. Here is what? 45. The man lies between, where his location is between north and what? East. In between north and east. By at which angle? It's not 45 degrees what? East. That is the man's what? Direction. Not 45 degrees what? East. But the magnitude is what? Root 2 what? Kilometer. So if you want to check the man's position, displacement is what? Root 2 kilometer north. This is the man's present position now. From where he started from. Is where he is now is what? Root 2 what? Kilometer north, 45 degrees what? East. That's the man's what? Displacement. So the man's displacement can be written like this now. This is actually how displacement should be written. The man's displacement is what? Root 2. Yeah. The man's displacement is what? What's going on here? These things are confusing us here. The man's displacement is what? Root 2 kilometer. You mention the magnitude first before the what? Direction. Root 2 kilometer is the magnitude of the magnitude. Then you now write the direction. The direction is what? Not 45 degrees what? East. Which is now not 45 degrees what? East. This is the man's what? This is 45. This is the man's what? Displacement. This is the man's displacement. Root 2 kilometer north, 45 degrees east. Is there any option here that looks like that? Option what? B. So this is the correct answer. Have you seen why I said that whether you are writing maths in JAMB or not? You should know JAMB, you should know mathematics. We entered maths here from physics. We entered mathematics. They are linked. They are linked. So this is the man's what? Displacement. You should, you know, before you can answer this question, you should know your what? Trigonometric ratios. You should know your what? Triangles. You should know them very well. Before you can answer this question properly, you should know BR in 2. You should know BR in 2. at least to a good extent before you can answer a question like this. And I know that immediately you saw it, you ran away. You didn't even bother to open it. It's only you that tried to do something. Chineke didn't even try to open it at all. But it's simple. I don't know why people are afraid of facing challenges. Anything you see, you don't want to think. Thinking is has gone. Thinking has actually gone. I don't know why. Students of these days, they don't like thinking. Anything that gives them thinking, headache, they don't want it. They want it very sharp, very, very, shortest means to grab it. They go their way. Does anybody has any question on this? Please ask. I wish that this is not taking our time today. Because you refuse to do your assignment. I am not happy. I must say, I am not happy. I must be sincere with you. I am not happy. I don't am happy. I am not happy at all. I believe we can do better than this. Why I use Tantita? I just use anyone I want to use. You can use sign. You can use cos. Well, it doesn't matter. Since we have found root 2, you can use sign. You can use cos. You get same answer. Even without punching your calculator, using your. I wanted to give you pain. I forgot. Why do you not want to correct the one he's giving you? Use this one. I forgot to give you one. I wanted to give you one, but I forgot. Even without punching a calculator, this is simple. You can use your trigonometric ratio and find it. Tan theta tan 45 degrees is what? 1. It's not true. Tan 45 degrees is what? 1. Sine 30 degrees is what? It's not half. On a clean. Did you do it in your first year? You're looking at me. You forgot to. It's okay. This is not farm tech class. I just asked because you and I'm sure you put it in your first year. All right, let's go to what's time, sir? 3 minutes to 6. Mary Rose, are you with us at all? You look so confused. Are you sure you're following us? It's when I give another question. I know whether you are following or not. So, any question? No question. So, in the absence of any question, we'll stop here for our physics assignment review, and see you next time.